Open up any tech news feed today, and you're instantly hit with a barrage of headlines throwing around AI, ML, deep learning, and generative AI. Most of the time, these acronyms get tossed into the exact same sentence. It creates this illusion that they are competing software products or entirely different tech companies battling for market dominance. But that's completely backward. These aren't rival technologies. They are actually a set of layers, nested inside one another, with each new breakthrough relying entirely on the structure built around it. To understand how a machine can suddenly write a sonnet or fold a complex protein, we have to strip away these layers from the outside in. Getting these definitions right is the only way to accurately grasp what a computer is actually capable of doing right now. That massive outermost shell is artificial intelligence. It is the broad scientific pursuit of building machines that can execute tasks that normally require human thought. For decades, this took the form of what we now call traditional AI. Researchers built expert systems by physically typing out exhaustive lists of rigid if-then logic rules for the computer to follow. This approach reached a peak in 1997 when IBM's Deep Blue defeated chess world champion Garry Kasparov. It proved that a machine could master a closed logic system simply by using massive brute force calculation to evaluate millions of potential moves. The catch was that the machine didn't actually know how to play chess. It ran the specific rules programmers provided, but lacked the flexibility to adapt. Drop that exact same supercomputer into a simple game of checkers, and it would immediately fail because it couldn't adjust to anything outside its pre-programmed boundaries. To fix that rigidness, researchers in the 2000s flipped the script. Instead of feeding the computer explicit rules to solve a problem, they started feeding it raw data. This is machine learning, algorithms designed to automatically comb through data, find patterns, and adjust their predictive models. Like when your inbox diverts junk mail, it wasn't programmed with a master list. It analyzed messages, noticed phrases like free money correlate with spam, and learned to filter them. Machine learning marked the transition to systems that actively refine their own logic as they consume more information. But standard machine learning hit a wall. As long as the data was neatly organized in spreadsheets or text logs, it thrived. Show it a messy, unstructured photograph or a raw audio recording, and the algorithms choked. That brings us to deep learning, handling massive data sets using artificial neural networks, inspired by biological connections in the brain. The word deep refers to stacked hidden layers. Each layer autonomously extracts a more complex feature, a sharp edge, an eye shape, then a complete human face. Google's AlphaGo illustrated the breakthrough in the game of Go, bypassing traditional move-by-move calculation to navigate the board using deep learned visual intuition. Deep learning gave computers the architecture to perceive and categorize the chaotic, visual, and auditory world around us with superhuman accuracy. Yet, for all its processing power, deep learning remained strictly discriminative. For decades, these neural networks were entirely focused on analyzing, labeling, and predicting outcomes for data that already existed. The innermost layer was reached when researchers realized they could run that exact same neural process in reverse. This is generative AI. By training massive models on volumes of text and imagery, the system learns the statistical distribution of human art. Instead of compressing an image to a label, it expands a prompt to synthesize something new, like drafting software code or generating photorealistic artwork. The machine has transitioned from a passive analyst parsing the real world into an active author generating completely novel artifacts. Returning to our initial framework, the relationships become clear. Generative AI requires the neural networks of deep learning. Deep learning relies on the data processing algorithms of machine learning, and all of it sits strictly under the umbrella of artificial intelligence. We've gone from machines that strictly followed hard-coded human logic to systems that extract patterns from raw data, to architectures capable of processing unstructured complexity, and finally to models that synthesize original content. Grasping these distinctions is highly practical. If a business needs to forecast quarterly sales from a spreadsheet, it needs standard machine learning, not a generative AI chatbot. Applying the right tool requires knowing exactly what each layer is built to do.
Looking forward, these specialized layers will continue to seamlessly integrate, creating systems capable of both automating mundane analysis and augmenting highly creative human labor. We have reached a turning point. Our tools have evolved from passive observers of the world into active architects of its future.